Hey guys, today we're going to do 311, Newton's method. Go ahead and try the warm-up. You're finding the extreme values of the function. So remember, you're taking the first derivative, setting it equal to 0, and testing those values along with the endpoints to see your max and your min. Okay, so number one, let's go ahead and do our derivative. We're going to use the chain rule. So we get 1/2 25 minus x squared to the negative 1/2 times negative 2x. Okay, our 2's can cancel. So we're just going to get a negative x over radical 25 minus x squared. Okay, we want this equal to 0. So our critical points are going to be obviously 0 because of the x on the top. And then 5 and negative 5 are also critical values because they make the denominator 0, but they're also endpoints. So everything's kind of included there. All right, so we're going to test our values. So we have f of negative 5, f of 0, and f of 5. We're plugging these into our original function. So we get 0 for the 5 and the negative 5. And when we plug in 0, we get radical 25, which is 5. So we're going to have max at 0 and min at 5 and negative 5. And if you looked at this, you might have recognized 25 minus x squared is like half of a circle, radical, so it eliminates the negative part of the circle, so it looks like this. So that's why it makes sense that at these 2 points we have our min, and then here we have our max. All right, number 2, same thing. So go ahead and find your first derivative. We have quotient rule here, so g prime of x equals derivative of the top is 1 times the bottom minus derivative of the bottom times the top over the bottom squared. We're going to reduce. So this gives us x squared minus 2x squared. So negative x squared, negative 1 plus 4x. Okay. So for critical values, if we look at our denominator, critical values would be 1 and negative 1 because they both make the denominator 0. Neither of those are in my domain that I'm supposed to be using, so I don't need to worry about that. In the numerator, we have a quadratic equation. It does not factor, so we're going to use quadratic formula to set this equal to 0. So we have negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so that is this. Okay, so we end up with 2 plus or minus radical 3. All right, let's talk about each one of those two options real quick. 2 plus radical 3, not in my domain, so I'm going to reject it. It's greater than 1. The other one would be 2 minus radical 3, and that is in my domain, so I'm going to test it. So I have g of 0, and I have g of 2 minus radical 3. I don't need to test 1 because it is not or equals 2, so it's kind of like those examples when we talked about maxes and mins and there was an open circle. We didn't have a max or a min there. All right, g of 0 is 2. G of 2 minus radical 3 is 1.866, and it keeps going. So it looks like my max is going to be at 0. And my min is going to be at 2 minus radical 3. All right, so today we're doing Newton's method. Newton, we're talking about actually Sir Isaac Newton. And so this was something that he came up with in 1664. It's pretty impressive, honestly, because they did not have graphing calculators. So when they were estimating things like the square root of a not perfect square, so like square root of 5, they were using this method to get it correct to however many decimal points they wanted. And I'm going to show you guys how to do that. So what we're going to do is we're going to start out with a guess. The closer our guess is to the actual number, the better, because we're going to get better results faster. Okay, and then we're going to use this formula here. So really it is just a formula. So it's xn plus 1 is equal to xn, meaning our previous guess, minus f of xn over f prime of xn. And that's going to give us a new guess, and then our next guess we plug into the same formula. Each time it's going to get more and more and more and more precise. Okay, you are going to need your graphing calculator today, so please have that handy. All right, so let's look at the first example. Find the positive root of the equation x squared minus 2 equals 0. So when you look at this equation, really we're finding x squared equals 2. So x equals positive or negative radical 2. So what we're really going to be finding today is the square root of 2 to however many digits accuracy we want, okay? In your homework, there's problems where I ask you to go to a certain amount of accuracy. And so what you're going to notice is each time we do this, the numbers repeat. And each time we do it, they repeat further and further on the decimal. So let's say you want it correct to the hundredths place. As soon as your thousandths place repeats, you can call it a day, right? So you just round it at the hundredths place and you're done. All right, so let's go ahead and try this out. First thing we want to do is we just want to have our derivative written down. So our derivative is going to be 2x, okay? So let's write down our formula now. So this is from the other page, and I'm actually going to plug in the specific values for this equation. So it's x sub n plus 1 is equal to x sub n minus, the top is f of x sub n. So in this one, it would be x sub n squared minus 2. Okay, remember I'm just using the function I was given in the problem. And then on the bottom, it's f prime of x sub n. So 2x sub n. There's my derivative I just took. Each one of these x sub n's represents the value that we got on the previous try, okay? All right, so now we're just going to make a little table. This is going to be x sub n, so it's like which one I'm on. And then over here is going to be x sub n plus 1. And that's where I'm plugging in my value from the previous one. Okay, so we're going to start out with a guess. Since we're doing the square root of 2, my first guess is going to be 1. Okay, so now I'm going to plug in 1 into this equation that I have, okay? So my next guess, x sub 1, I'm plugging in 1 for all of my x sub n's. Okay, so I'm going to get 1 minus 1 squared, which is 1 minus 2, over 2 times 1, which is 2. So that's 1 minus negative 1/2, which is 1.5. Okay, so that's my x1, 1.5. So my x2 is going to be the same equation, plugging in the 1.5. So 1.5 minus 1.5 squared minus 2 over 2 times 1.5. Okay, I'm going to put that all into my calculator, and I get 1.4 1, 6, repeating. That now is my x2. And so my x3 is going to be the formula plugging in the 1.416 repeating. Okay, so this is a good time for me to teach you, and some of you probably are already doing it, a good little strategy to use. So each time you plug this into your calculator, when you get this final answer here, you want to store it as x. Okay, and then you just recall your formula that you already plugged in. Okay, so that would be this one right here. So you're gonna just store it, recall, enter, store, recall, enter, and that just gets you going really, really quickly with each one right after the next. And you don't have to write all of this stuff down. You can just write each guess as it goes, okay? So why don't you try that? If you have this on your calculator, go ahead and store it. Okay, type in your equation, get your answer, store it again, recall your equation again, and hit enter. Okay, and then pause this video, and when you're ready, let's look at what you got for x3. Okay, so for x3, I got 1.4142.156.86 ... Okay, and then you're going to store that as x. You're going to recall your formula that you used, and that's x3, okay? So now, I'm not going to rewrite it, but go ahead and find your x4 now using that. And then hit pause when you're ready. Go ahead and play. So I got 1.4142135562. Okay, so what I want you guys to notice right now, we are correct up to here. Do you see how that's repeated on the previous one and on this one? So that is for sure right. And as you keep going, it's going to repeat longer and longer and longer. However much of it repeats is the stuff that you know is absolutely correct. Okay, so this is Newton's method. We're going to go ahead and try number 2. So on today's notes, I didn't say find correct to however many decimal points. So it's either going to say that, or it might say like find up to x2 or x3, and then that's just how far you go. All right, let's look at number 2. Find the x coordinate of the point where the curve y equals x cubed minus x crosses the horizontal line y equals 1. Okay, so we want where x cubed minus x is equal to 1. Okay, let's actually subtract that. Subtract the 1. Okay. And now I'm going to use intermediate value theorem to kind of narrow down where my root is going to be. Okay, so let's say this was my f of x. Let's say it was the x cubed minus x minus 1. So if I had like f of 1, 1 minus 1 is 0, minus 1 is negative 1. Okay, if I had f of 2, 8 minus 2 is 6, minus 1 is 5. Okay, so I know my root is between 1 and 2 by the intermediate value theorem. All right, so we're going to use Newton's method. So first thing we want to do, find our first derivative. So that's going to be 3x squared minus 1. And now I want to set up my equation. So it's going to be x sub n minus, now I want my original equation. So that's going to be x sub n cubed minus x sub n minus 1. And then on the bottom I have my derivative equation. Okay, so this is what I am typing into my calculator, and then my guesses are going to be stored each time as I go. All right, so let's set up our little chart here. So this is going to be what number I'm at, n. This is my x sub n, and this is my x sub n plus 1. All right, so my first guess, my n is 0. I'm going to go with 1. And the reason I want 1 is because when I figured out this, which one was closer to 0, it was the 1 was closer to 0 than the 2. Okay, so I'm going to do my first guess is 1. All right, when I plug 1 into this yellow equation that I circled in my calculator, so store x as 1, type in that x equation that we have over here in yellow, and then I'm going to go ahead and hit enter. I get 1.5. Okay, so now my n at 1, x sub 1 is 1.5. And I'm storing the 1.5 as x. I'm recalling my equation that I circled in yellow, and now I get 1.347826087. Okay, that is now my x2. Okay, so I'm going to store that as x. I'm going to type it back into my equation, recall my equation, and so the next one I get 1.325200399. Okay, so that's my x3. Okay, and so now I'm storing that in my calculator, what I got there. I'm plugging it in again. So my x sub 4 now is going to be 1.324718174. And you can see I'm slowly getting more digits correct each time. Okay, when I store that one, my x5 is 1.324717957. So it looks like now I'm correct up to 5 digits. And when I go one more time, I actually get this exact same thing repeated. So this, everything I could see on my calculator screen, since the whole thing repeats, this is correct up to this many digits. Okay, if you were to type into your calculator the x cubed minus x as your y1 and your y2 as 1, and then you do an intersection, you should get this answer back if you were to check that. Okay? All right, so this is Newton's method. Go ahead and try your homework problems. Let me know if you need any help. I hope this made some sort of sense. I hope you were doing it along on your calculator, because if not, it really makes no sense. And just let me know if you have any questions. Thanks, guys.